Once in a very great while, we get a rare, totally accidental peek behind the curtain of some major piece of tech. And today, we've got a really fascinating one. A build system mishap accidentally leaked a map file for Claude's command line tool, and that little mistake was all an engineer needed to decompile it. Now here's the kicker. They used AI to analyze that decompiled code, and it generated this incredibly detailed breakdown. So what we're looking at today is that analysis, an accidental blueprint of a top-tier AI assistant.
So you gotta wonder, right? What does the code behind a powerful AI like Claude actually look like? What kind of clever tricks, security measures, and just wild architectural decisions are hiding in there?
Well, thanks to that leak, today's the day we find out. We are going on a little digital archaeology trip, digging through the bones of this powerful tool to see exactly how it's put together from the ground up.
And look, this isn't just about being nosy. As the person who analyzed the code points out, there are patterns and approaches in here that are absolutely worth studying. This is basically a masterclass in high-performance, security-obsessed AI engineering. Okay, let's dive right in.
First up, let's talk about the user interface. And I know what you're thinking. It's a command line tool. How complicated could it possibly be? Well, the answer is shockingly complex. They didn't just build a UI, they basically built a game engine, but for text.
This whole process is just wild because it's almost exactly how a video game renders a new frame on your screen. They take the components, figure out the layout, and then draw it onto this 2D grid of characters. Think of it like a buffer of pixels. Then, and this is the really clever part, it compares the new grid to the old one and only updates the tiny little parts of the screen that actually changed. That is just unbelievably efficient.
And they for sure did not just grab some standard library off the shelf. No, they customized the heck out of it. We're talking a full-on event system for mouse clicks, virtual scrolling to handle huge amounts of text without slowing down, and even hit testing so it knows exactly where your mouse is pointing. This feels less like a terminal and way more like a high-end desktop app.
This obsession with speed, it just goes deeper and deeper. They're using tricks like bit packing, literally cramming styling info into a single bit so they can check it at lightning speed. They tap into the terminal's own hardware scrolling to avoid having to redraw everything. It makes one thing crystal clear. For this team, performance wasn't just a feature, it was the whole point.
All right, so we've seen the skin of the app. Now let's get to the brain. How does Claude actually do its work? Well, it all starts with its core logic and this massive toolbox it has. Right at the very center of everything is this thing called the query loop. The best way to think about it is as the AI's conductor. It listens to your request, figures out which tools it needs from its orchestra, gets them all playing in harmony, sometimes many at the same time, and then pulls all their outputs together into one final coherent answer, all while keeping a close eye on its resources.
And man, what a toolbox! It can run shell commands, it can read and write files, it can plug into external programs, but check out AgentTool and Tool Search Tool. This thing can spin up other AIs to work on problems in parallel, and it can even go looking for new tools it wasn't aware of before. This is a system that's literally designed to grow and expand its own skills.
Okay, so giving an AI access to your files and your command line, I'm sure that raises a pretty big question in your mind. Is any of this safe? Well, if the code shows the engineers were asking that exact same question, and their answer was to build an absolute digital fortress, taking a really paranoid defense-in-depth approach to security.
First off, you are in control. The default mode is interactive. It's going to ask you for a yes or a no before it does anything even slightly risky. Plan mode is even safer. It's basically read-only. And then you have bypass mode. This mode is so dangerous, they literally put the word dangerously in the command you have to type to turn it on. That tells you everything you need to know about how they view the trade-off between power and safety.
But it goes so far beyond just simple permissions. This system is actively hunting for threats. It's smart enough to find hidden commands buried inside other commands. It can block attacks that are unique to specific shells, and it even understands text editing commands like sed, just to make sure the AI isn't trying to pull a fast one. It even protects its own settings files from being changed. This isn't just careful engineering, it's paranoid engineering.
So we've got a super sophisticated UI and security like a fortress. But maybe the most futuristic piece of this entire puzzle is its ability to not just be one AI, but to build and manage an entire swarm of other AIs.
And you even get choices for how to run these sub-agents. It can run them inside the same process for maximum speed, or it can pop them out into their own separate terminal windows using tools like tmux or iterm. This gives you, the user, this amazing flexibility and a clear window into what that AI swarm is actually up to.
And this all leads to something called coordinator mode. Now, in this mode, the main AI, it doesn't really do the heavy lifting itself. Instead, it becomes a project manager. It takes a huge, complex problem, breaks it down into smaller pieces, and then delegates those pieces to specialized worker AIs. It then manages them as they all work in parallel to crush the goal. I mean, this is a real glimpse into the future of how we'll solve complex problems.
Okay, so let's zoom out for a second. What does all of this actually tell us? When you peek inside this code, you start to see this set of core philosophies that are clearly going to shape the future of this kind of software. So here's the bottom line. The user interface is built with the precision and seriousness of a graphics engine. The security is paranoid by design, trying to stop attacks before they even have a chance to start. The whole system is meticulously built to be efficient with memory, which is crucial for long sessions. And maybe most importantly, it's designed from the ground up to handle all the weird quirks and needs of working with large language models.
And that really leaves us with one final huge question to chew on. What we're looking at is a command line tool that is engineered with the complexity of a modern operating system, from its graphics pipeline to its process management to its security layers. So what does it mean for the future of all software when this becomes the new baseline? That is something to think about.